Hey, I'm Tyler, and in this video, we're going to talk about balancing chemical equations for the TEAS exam. This video is part of my TEAS Chemistry Essentials full course, and this course covers all the most important chemistry topics you need to know for the TEAS. Here they are right there. And the course goes in a really patient, step-by-step way. You can find the full course at teasinOneday.com. And if you have any questions or comments about these videos or about the TEAS in general, you can always email me at tyler@teasinOneday.com. Okay, so the process of balancing chemical equations is a little bit like a math puzzle or Sudoku or something like that. The way to learn is just work through a bunch of examples until you get the hang of it, and that's what we're going to do here. Now, this video is going to be a little bit different than some of the others that I have for the TEAS. Many years ago, I made a YouTube video on balancing chemical equations, and I think it's really good. It's helped literally millions of people learn this skill. So the first thing we're going to do is we're going to watch part of that video. Now, the style is a little different, and I look a lot younger in it, but the information is still really solid. Then, after that video is over, old me will come back and we'll do some TEAS-style practice problems. Sound good? Let's get going. Let's do some practice problems for balancing chemical equations. We'll start off with some examples that are pretty basic and straightforward, and then the problems will get more challenging as we move on. Here's our first equation. We got xenon and fluorine. We want to keep track of how many atoms of these elements we have on both sides of the equation, so we're going to make a little chart, okay? I got xenon and fluorine on this side, and then xenon and fluorine on this side. Over here, I have one xenon atom, one, and then I have F2, so I got two fluorines. Over here, also one xenon, and then F6, so I got six fluorines. Now take a look at these numbers. This equation isn't balanced yet because we have different numbers of the atoms for one of the elements. I've got two fluorine here, but I've got six fluorine here, so it's not balanced. In order to balance it, I've got to add numbers or coefficients in front of one or more of these elements and compounds to change the number of atoms that I have on the different sides of the equation. Okay? Here's how I'm going to do it. I got six fluorine here, but I got two fluorine here. So for this to balance, I need more fluorines on the left side. I can add a number in front of the F2 here. If I put 3 in front of this F2, here we'll put it in. If I put 3 in front of this F2, now I have 3 times 2 gives me 6 fluorine, and now they balance. 1, 1 for the xenons, 6 and 6 for the fluorine. So now this is a balanced equation by adding this number, by adding this coefficient. Now really quick, this is one very common question. People often ask, wait, why did you put that 3 there? Couldn't you just change this 2 to a 6 and then it would also balance? No, 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 no. You can't do that. Super common misconception. You can't change these subscripts here. You can't change them, you can't add them. So you can't change this to a 6, you can't put a 6 here or anything like that. The only thing you can do is you can put numbers in front of the elements or compounds, okay? But you can't change or add the subscripts. Okay, so that's how you balance an equation. Let's do a whole bunch more practice. Okay, so in this equation we've got 3 elements: silver, Ag, hydrogen, H, and sulfur, S. Obviously we've got these on both sides of the equation. Okay, so let's see how many atoms we have of each. Over here we got 1 Ag, we got H2, so we got 2 hydrogen atoms, and then we have S, so we got 1 sulfur atom. Over here we have Ag2, so we have 2 silvers here. Sulfur, we have 1, and then we have H2, so we have 2 hydrogens. Okay, what balances and what doesn't? Well, the hydrogens and sulfur both balance, but the silver, we have 2 here and 1 here. We can fix it by adding a number or coefficient in front of one or more of these elements and compounds, I need more silvers on this side, and luckily, I can just put a 2 in front of this Ag. So now instead of having 1 Ag, now I have 2, and now I got 2, 2, and 1. It balances. This equation is a little bit more challenging because we have oxygen in all the compounds here. That means that we're just going to have to be a little bit more careful when we're adding up the number of oxygen atoms that we have. Okay? So the elements in this equation. We got K, potassium, O, oxygen, H, hydrogen, and C, carbon. And over on this side, we've got potassium, oxygen, hydrogen, and carbon. Okay, how many of each of these do we have? Okay, we got 1 potassium here. Now for oxygen, this is where you just got to be a little bit more careful, okay, because we have 1 oxygen here, but then we have 2 oxygens here. So 1 plus 2, total we have 3. Then hydrogen, we got 1 of those, and carbon, we got 1 of those. Over here for potassium, we have 2 of these because we got K2. Then oxygen, we have 3 there, and we have 1 there. It's going to give us 4 total. Then we have H2, we have 2 hydrogens, and 1 carbon. Okay, so what balances, what doesn't? The carbons balance, but other than that, we've got to add some coefficients to change this stuff around. Okay? Oxygen doesn't balance, but since oxygen is in every one of the compounds, I'm going to leave that for later. I'm going to start with potassium because it's easier, right? I have 2 potassiums here, but I've only got 1 here. So the first thing I'm going to do is I'm going to put a 2 in front of this KOH, and let's see what that does. Okay, the first thing that's going to do is it's going to give me 2 instead of 1 potassiums, because I have the 2 times K. Now for oxygens, let's look at how it's going to change that. Now I'm going to have 2 oxygens, because 2 times that, plus the 2 that I have over there in CO2. So I'm going to have 2 plus 2 is now going to give me 4. So I've got 4 oxygens. And in terms of hydrogen, now I'm going to have 2 times 1 hydrogen, so I'm going to get 2 hydrogens. And check it out. Putting this 2 here changed everything. So now I've got 2, 4, 2, 1. It all balances. Now we're going to start doing some equations that require more than one step to balance. Okay, so this one here has sodium and chlorine. Over here we got 1 sodium and we have Cl2. We have 2 chlorine atoms. Over here we have NaCl, so we have 1 sodium, 1 Na, and 1 Cl. Okay, how am I going to start? Well, I have more chlorine on this side. I have 2 over here and I only have 1 here. Okay, so I can start out by putting a 2 in front of NaCl. Okay, that's going to give me 2 Cl, but look what else it's going to do. Okay, now I have 2 times Na, so I have 2 Nas. I also have 2 times Cl. Okay, so I also have 2 Cls. So now the Cls balance, but now I have 2 Nas, 2 sodium on this side, and only have 1 on this side. So now to balance this out, I'm going to put a 2 in front of this Na here, and now I have 2 of these. So now on both sides of the equation, I have 2 sodiums and 2 chlorines. The equation balances. Okay, iron, oxygen, and carbon. Over here I have 1 iron, 1 oxygen, and 1 carbon. Here I have 1 iron, 2 oxygens, and 1 carbon. Okay, how am I going to balance this? The first thing I'm going to do is I'm going to balance these oxygens. Okay, so I have 2 over here and I have 1 here. I'm going to change that by putting a 2 in front of the FeO. Okay, so that's going to give me 2 oxygens, but it's also now going to multiply this Fe by 2. So now I'm going to have 2 Fe. Okay, so now I've got 2 Fe here and 1 there, so now these don't balance. So the next thing I'm going to do is I'm going to put a 2 in front of this Fe there. So now instead of having 1, I have 2 of them. Now I have 2, 2, 1. It balances.
All right, so now that I've gotten a little bit older, let's work through the type of questions that you'll see on the TEAS. Here's a first one. The following equation shows a catabolism of glucose. How many oxygen atoms are present on each side of the equation? Now,
if you get a question like this, you're very lucky because you don't actually have to do any balancing. The equation is already balanced. We got these numbers here. You just have to worry about correctly counting the number of oxygen atoms. But there's a reason why this is a TEAS question. It can be trickier than it seems, and a lot of people get tripped up. So let's break it down. Here's the equation. I recommend writing equations down like this on a piece of paper so you can work through all the math. Let's start over here with the left side. Here's what we're going to focus on. The oxygen atoms, okay? In C6H12O6, there are O6, 6 oxygen atoms. Then we have O2, and we have 6 of them. We have 6 O2s. Now, each O2 has 2 oxygen atoms. So we want to do 6 times 2, and for that, we'll get 12 total. So that's going to be 6 plus 6 times 2 equals 18. 18 total oxygen atoms. Now, this equation is balanced, so it should be the same number of oxygen atoms on both sides. But we can do the other side real quick just to check ourselves. And sure enough, we have 18 oxygens here too. We have 6 CO2. Each CO2 has 2 oxygens. So we have 6 times 2, or 12 here. And then we have 6 H2O, and each H2O has 1 oxygen. We have 6 of them. So we have 6 times 2 plus 6 equals 18. 18 on both sides, and that is choice C. Now, just to warn you, a lot of people will actually mess this up because they'll see the 6 here and the 6 here, and they won't notice that it's O2 here and CO2 over here. They'll just see the 6 and the 6, and they'll think 12. And look at this. Choice B is right here with 12 to trap you. It's just waiting to trip you up. Okay, here is the next example. When the equation below is correctly balanced using the smallest whole number coefficients, the coefficient of H2 is... Okay, let's get to work. First things first, write down the equation, just like this. And then we'll do a chart for the number of atoms. On the left side, what do we have? We have 2 hydrogen, H2. We have 3 iron, that's Fe. And we have O4, 4 oxygen. And on the right side, we have 2 hydrogen, H2. We have 1 iron, and we have 1 oxygen. Let's start balancing out the irons. We have 3 on this side, and we have 1 on this side. So we'll put a 3 here in front of iron. And now we have 3 Fe. Okay, so now the irons balance. What next? Well, the oxygens don't balance. I have 4 here, and I have 1 here. So we can put a 4 in front of H2O. And now we have 4 oxygens because each H2O has 1 oxygen. We have 4 H2Os. We have 4 oxygens. But putting a 4 there also affects the number of hydrogens we have. It's H2. So if we have 4 of these, it's going to be 8 total hydrogens. 4 times 2, 8 hydrogens. So the last thing we'll do is we'll balance these hydrogens. We've got 8 on this side, and we've got 2 over on this side. So to get 8 on the left side over here, we'll put a 4 in front of the H2, and that gives us 4 times 2, which is 8. And now everything balances. So the question is asking about the coefficient in front of H2, and that in the properly balanced equation is 4, which is going to be
choice C. Okay, and be on the lookout here for D. A lot of people will think, oh, we need 8 hydrogens, and they'll see that 8, and they'll pick it. Classic TEAS trap, okay? It's looking for the number in front of H2. It's looking for the coefficient. It's not looking for the total number of hydrogen atoms. Okay, last question. Which set of coefficients correctly balances the following chemical equation? Okay, so we got to balance it. Then we'll look at what the coefficients are, and then we'll choose the correct answer. Okay, so step 1. You want to write down the chemical equation and make a little table for the atoms on both sides. On the left side, we have 1 silicon, we have O2, so that means 2 oxygen, and we have 1 carbon. And on the right side, we have 1 silicon, we have 1 oxygen, CO, and we have 2 carbons, right? We have 2 carbons because we have 1 carbon here, and we have 1 carbon here, so it's going to be 2 carbons. Okay, let's start out by balancing the oxygens. We have 2 oxygens here, 1 oxygen there. So we can just put a 2 right there, okay? When we put a 2 there, it gives us 2 oxygen, and it also affects the number of carbon that we have, right? So now we have 3 carbon on the right side because we have 2 carbons here, and we have 1 carbon there. So our total number of carbons is 3. Okay, so what balances, what doesn't balance, okay? Silicon balances 1 and 1. Oxygen balances 2 and 2, but carbons don't balance yet. I have 3 on this side and have 1 on this side. How can we fix that? Boom. We'll put a 3 there in front of carbon, and now we have 3 carbons. The atoms on both sides perfectly balanced. Now, what are the coefficients here? Well, remember that if there isn't a number in front of something, the coefficient is technically 1. So that means that the correct choice here is B. It's 1, 3, 1, and 2. Choice B. All right, so that's it for balancing equations. By now, I bet you've gotten pretty solid with this stuff, and you should be in good shape for the TEAS. Listen, if you like how I teach, if this video is helpful to you, you can find the TEAS Chemistry Essentials full course at teasinOneday.com. I cover all of the most important chemistry topics for the TEAS, and I go in this really patient, step-by-step way. And if you have any questions or comments, you can always send me email at tyler@teasinOneday.com. Best of luck with the TEAS.